Good morning, ladies and gentlemen, even though there are only two. And welcome to the third annual Women's Day. For those of you who do not know me, I'm Jane Rittmaster, a member of the Auxiliary Board and one of today's co-chairs, and I'm really happy to see all of you. I think this topic has driven an awful lot of people in here. The best part of this morning, though, so far, is that you remembered to come, and what lecture you signed up for, and what room you were told to come to. Thank you all for your generous support of today's event. Proceeds will benefit women's health initiatives. With 7 hospital campuses and over 45 ambulatory practices citywide, there is always a Mount Sinai doctor at your fingertips. The Mount Sinai Health System cares for so many family and friends, and I'm delighted to support their efforts to vastly improve women's care. It is now my pleasure, and the only reason you came, to introduce the fabulous doctors who will address today's topic, Where Did I Put My Keys? To my immediate left is Jane Martin. Dr. Martin is an assistant clinical professor in the Department of Psychiatry at the Icahn School of Medicine at Mount Sinai, and the director of the Neuropsychological Testing and Evaluation Center, also at Mount Sinai. Next is Dr. Judith Neugroschel, rhymes like New Rochelle, who is the director of the Neuropsychological Service at the Icahn School of Medicine. She is also the director of the Mount Sinai Alzheimer's Disease Research Center, the director of the Satellite Core, and the co-director of the Education, Recruitment, and Outreach Core programs. Lastly, but not least, is Dr. Margaret Sewell, who is an assistant professor in the Department of Psychiatry at the Icahn School and the director of the Outreach, Recruitment, and Education Core programs at the Mount Sinai Alzheimer's Disease Research Center. And now I turn the podium over to them.
Good morning. I'm Jane Martin, and I'm just going to redo those introductions because anytime you do anything more than once, that's how you get it encoded in your memory. So let me start again. I'm Jane Martin. I run the Neuropsych Service. That's the Cognitive Assessment Center at Mount Sinai. To my left is Dr. Margaret Sewell, Meg Sewell, who is the director of the Education Core of our Alzheimer's Disease Research Center. That's our ADRC at Mount Sinai. There are 30 of them around the country. We are the oldest, I think, right? The oldest? So you could say it again. And the Education Core. Dr. Judy Neugroschel is the medical director of our ADRC, and she'll be talking about current research, clinical trials, changes in diagnosis, neuroimaging, genetic risk factors. Dr. Sewell will be talking about lifestyle factors, and Dr. Mary Sano luckily was able to join us. She's just back from Barcelona, where she was attending the CTAD, the Clinical Trials in Alzheimer's Disease Research. So let me just start. We've been given about 10 minutes each. This is a feat for us because we all have so much to say and so much information to give you. So I'm going to give you a brief overview of memory functioning. The metaphor that we like to use is a library. Think of it. You've got to get the books in. You've got to store them in some way. Can't throw them on the shelf so that you can retrieve them. Same thing with our memory functioning. We have to get information in from the world, encode it, store it, so that later we can retrieve it. So what we're really talking about is acquisition, storage, and then retrieval. In terms of memory processes, you probably all heard long-term, short-term memory. People say, oh, I remember things from 40, 50 years ago. I can't remember what I did last week. That's typically how it works, even with normal aging. So long-term memory is really about the things that we learned long ago, school-based information, autobiographical information, my address as a kid, versus let's talk about working memory. It's a kind of a short-term memory, which we think of as a little scratch pad, a holding ground. It has a limited capacity. So that's why when you ask a friend, give me that phone number, for whatever, a restaurant, I want to just call and say I'm running late, you remember it just enough time to call the restaurant afterwards, it's gone, right? Because you really didn't want to remember it. If you wanted to, you'd have to actively do something to encode it. Everybody always asks, what affects my memory? Lots of factors affect your memory, and I'm only going to rattle them, but Dr. Sewell is really going to expand on them. Things like diet, she'll talk about, diabetes, fatigue, sleep, alcohol use, head injury. Please wear helmets, wear seatbelts. Really puts you at risk for developing dementia, head injuries. And then what I call the psychological or emotional factors, stress, overload, depression, anxiety. And I just want to comment on depression. Really toxic for the brain. Important to get a handle on it. What depression does, think of any friend you know who's depressed. They're slowed, they walk slow, they talk slow, they don't have a lot of energy. Well, they might move slow, but they also process information slowly, and their attention is what is disrupted. Depressed people talk about, I can't concentrate on a book anymore, I can't focus, and when you can't pay attention well, obviously your memory suffers because you're not focusing and attending, can't get the information in accurately so that you can encode it. So depression's important to treat. We see people who have a pseudo-dementia. Looks like they are starting to have signs of dementia when in fact it's really due to depression. So, attention. If you leave here today with, I hope you leave with more than one thing, but one thing is really about attention. It is the easiest way to boost your memory. Most memory problems have more to do with acquisition, the getting it in, versus the retrieval, the pulling it out. So when you say, I can't remember that woman's name I met this morning at the Mount Sinai Women's Health Conference, and I'll say, no, you didn't forget her name. You probably weren't really paying attention when you were introduced. So it didn't get in. So, of course, you're not pulling it out. This happens to kids with ADD as well. So what are the realities of normal aging? There is gradual change as we age. A little bit is normal. Word finding difficulty, right? That tip of the tongue, can't think of the word or the name, get me the whoojamacallit from the kitchen. That starts at about age 30. Do you feel better now? Okay. Right. Starts at 30, so a little bit of that is normal. However, there's no way to know if it's more than it should be when you're 50 or 60 or 70 without really coming to a team like us and getting an evaluation. And I'll go to that in a few minutes. So a little forgetfulness doesn't really interfere with our everyday life. When people worry is it more than friends my age? Is it more than it was a year ago? And that often signals the time to say, come and get an evaluation. And sometimes we see people who we call the worried well. They're just nervous and worried, and the evaluation provides a baseline for them. And sometimes there really is a change. We'll get back to that too in a second. It's also harder to focus as we get a little older, right? Attention is easily disrupted. When you're young, you can do your homework with music on, focus on 9 things. As you get older, you better be darn picky. But we can learn new things. So people start learning a new language at age 70. Sure, you can do it. It's a little harder. And the reason we can continue to do this is the brain is an organ. It keeps changing, and we refer to it as it has plasticity. It changes, and it's always adapting, and we can continue to make new neural connections in the brain, perhaps just fewer. Let's move now to Alzheimer's. I want to say that last year, the Alzheimer's Association put out a statistic that said it is the second most feared disease, next to cancer. So it's above heart disease, it's above diabetes. I mean, who would think that they would make a movie about Alzheimer's, Still Alice? It is there in the forefront now. Nobody's hiding. Everybody's coming out, worried, wanting to check. The other thing that I always like to clear up when I speak to an audience is, what's the difference between dementia and Alzheimer's? A lot of people ask that. So let's get that cleared up. Dementia is the broad umbrella term, and underneath it are different kinds of dementias, and the most common is Alzheimer's. The second most common is vascular dementia. And then there are some others, like Parkinson's dementia, because Parkinson's is also, like Alzheimer's, a neurodegenerative disease, and eventually that you have dementia, but it's due to the Parkinson's disease. alcohol dementia. And Lewy body, a little lesser known, a different presentation, there are visual hallucinations, and I think Robin Williams, the actor, it's now come out that he had Lewy body dementia, which is helpful in a sense for us because it puts, again, something in the forefront to think about for research. So Alzheimer's, as I said, irreversible, I think, I hope not, a progressive, steady decline in neurodegenerative disease. But it's not part of normal aging, and we see many people in their 90s we have in our clinical trials who are cognitively intact for their age. So it's characterized by memory loss and usually some other cognitive changes, as well as later in the disease, some behavioral and personality changes. I want to briefly say something that's in the middle. So let's think of a continuum. We have normal aging on one end, and we have Alzheimer's on the other end. Well, I call it the gray zone in the middle. It's called mild cognitive impairment. Anybody hear of that? MCI, mild cognitive impairment. So what that really means is you have some cognitive changes. You come in and you take a series of tests, and maybe your performance isn't quite where it should be for your age and your kind of lifelong abilities, but you don't have Alzheimer's, or you don't have it yet. So there are changes, and we hope that people who have mild cognitive impairment stay in that gray zone. We're not sure really who converts and who doesn't. But we do know the rate, I think it's about, and Dr. Sano will back me up, about 15% a year. So in about 3 years, if you've been diagnosed with MCI, mild cognitive impairment, about 45% of people convert, as we say, cross the line over to Alzheimer's. So, am I almost there?
You're good. You got 3 minutes.
I got 3. This is a challenge. And as you see, even we know this stuff, we bring papers, we bring lists, because that's what you need to do. Those are the tools you need. So if you're worried, what does it mean to come and have a cognitive assessment, neuropsychological testing, memory testing? You call it all of the above. It is a battery. It's about 3 hours that you'd spend with us at Sinai. It's a battery of paper and pencil tests that tap or kind of mirror brain functioning, different parts. So I always point to my brain, but we have tests that tap memory, tests that tap attention and concentration, visual spatial functioning. So your father-in-law who's getting lost, we have tests that would tap into why that's happening, language abilities, and then what we call the front of our brain executive functioning. People never come into us and say, I'm really worried about my executive functioning. Everybody comes in and says, I'm worried about my memory. And the second thing is, I have word finding trouble. I can't think of the names of things. But often it is about executive functioning. And that's involved with planning and organization, problem solving, judgment, and anything in everyday life that requires really multi-steps becomes difficult. For example, balancing a checkbook, paying bills, working a cell phone, a computer, these activities. So I feel like I missed a sheet here. Okay. So risk factors, I think my colleagues are going to go into that more, but obviously age is a risk factor. I think if you're 85, about 50% of people will have Alzheimer's in this country. Cardiovascular risk factors, just remember, again, this will be covered. Whatever's good for your heart's good for your head, so you really want to watch things like head trauma, cholesterol, hypertension, stroke. The main thing is treat what's treatable. You have high blood pressure, take your medicine, wear helmets, practice good memory habits, and again, focus your attention. And if there's a worry, come to us and get an evaluation. Thank you very much. How do you do with time? Okay. 10 minutes. Oh. This is how we compensate.
Okay. I'm short, so they had to go get me a box to stand on. So the first question that people usually have now is, okay, so what can I do to reduce, I see heads already nodding, I haven't even said it yet, you know what I'm going to say. What can I do to reduce the likelihood of developing Alzheimer's disease, and what can I do to reduce the effects of cognitive aging as I get older? And it's a question everybody has, and a lot of people are studying. And in the past year, the IOM, the Institute of Medicine, came out with a big report that you can read online that reviewed virtually all of the studies at the time in this area to figure out what works and what doesn't. And they essentially divided them into two columns, one that were the best evidence for working and one that had some evidence for working. And the studies that fell in the best evidence for working were things to do with getting more physical activity and physical exercise. One, and two, as Dr. Martin just alluded to, controlling what we call your cardiovascular risk factors, your hypertension, your high cholesterol, your diabetes, obesity, smoking, all of that stuff, reining that in under control. The other column, under the some evidence column, were things that we call cognitive stimulation studies, which I'll come back to in a second. But in the physical side of things, the going recommendation is that everybody gets at least 150 minutes a week, that's 2.5 hours, of moderate aerobic physical exercise, and at least 2 times a week of muscle strengthening exercises. Now, everyone's nodding. You've probably all heard that already in 1,000 magazines. The trick is, of course, doing it and continuing to do it. So a lot of studies suggest that people start out and then they kind of fall off the wagon. And of course, that's never happened to me, but maybe it's happened to some of you. So there are studies that suggest ways to not fall off the wagon of exercise include having an exercise buddy. It helps with motivation. It helps with accountability. If your girlfriend's on the corner with their sneakers on, you gotta go, okay? So that's something to keep in mind. The diet issue, the research in terms of what we should be eating, the results are a little more inconsistent. So there are a bunch of studies that suggest following a Mediterranean-style diet, and there's many names for this in the literature, but basically the leafy greens, the whole grains, the fruit, a little bit of wine, the fish, less on the meat, less on the dairy, less on the sweets, that following that kind of diet is good for you cognitively. There's some studies that suggest that people who are super disciplined about following that diet have even better cognitive effects. But then we introduce this thing when you look at research of a web where you're like, what is contributing to these outcomes? And it's very hard sometimes to tease it apart. So is it the diet? Or is it that someone who is super disciplined like that is also engaging in many other kinds of behaviors that are contributing to cognition? And it's very difficult to tease all of that apart. We don't really know at the end of the day whether exercise is going to improve your cognition. There's actually been some research since this IOM report that says, oh, we may need to study this more. The results are not necessarily as strong as we originally thought. But we do know for sure that exercise is good for your heart, and as Dr. Martin just said, what's good for your heart is good for your brain, and so there's certainly a common sense element in this that we should get off the couch. Okay, so on the other side is our some category. This is the cognitive stimulation studies, and what is that? So it's not just crosswords. Okay, people are obsessed with crosswords. I don't know, don't worry about it. You don't have to do crosswords. Cognitive stimulation is any kind of activity that is novel, that is varied, that is challenging, okay? And studies have been very broad in what they've looked at. They've looked at people who go and study a musical instrument, take dance classes, do arts and crafts, get really good on the computer, people joining book clubs, and results from a bunch of these studies have showed that people do better on cognitive tests, like what Dr. Martin was just referring to, than people who do less of those kind of activities. So then we're back to the web again. So what does that mean? Is it really due to the arts and crafts, et cetera? Or is it due to the socialization that is a part of many of those things I just talked about? So there's a whole other area of research that looks at the cognitive benefits of socializing, just doing what we're doing right this second. And again, this is something that's pretty hard to tease out. Is it the socialization? Is it the activity? Is one better than the other? Is two better than neither? And these are good questions that people are continuing to study, but we're just not sure of the answer to that yet. Another problem with research in this area is some of these outcomes. So let's say you do better on my memory test in my lab, so that's great. But then what does that mean, really? What does that mean for what's really going on in your brain? And what does that mean in your daily life? Doing better on my memory test may not be something that you can actually notice in your daily life. So these are some of the issues that scientists grapple with when they're doing research in this area. So let's assume now that you've set the stage for improving your cognition. You're doing the diet, you're doing the exercise, you're doing the cognitive stimulation activities, you've controlled your diabetes, you've dealt with your depression, and I want to highlight how important that is. Okay, so what else can we do? Now you've got this beautiful stage. First of all, there are hundreds of books about memory techniques that have been published, a lot in the last 10 to 15 years, with about a 90% overlap of the exact same information. So when people say, do you recommend one book over the other? I really don't. They talk about plain, simple memory techniques that involve using idiosyncratic associations and powerful visual images to learn information and then be able to pull it out later. And guess what? The techniques do work. The trick is that you have to do them and you have to practice them. So my recommendation for the books is to pick one that you like, one that is written in a style that appeals to you, and pick a couple of their techniques and really work on them, because they really do work. But there's three other things I think you can do that may make you notice a change in your daily life even more, that are more basic. And the first of those things is simply to slow down the rate of information that you're taking in and what you're trying to learn. And I say this, part of it is sort of common sense, but part of it comes from research that shows the difference in memory performance on my tests amongst older people and younger people. A lot of that variance is accounted for by processing speed. And as Dr. Martin just said, as we get older, our processing speed does slow down a little bit. It's not abnormal. But that just means that for the 30-year-old and the 70-year-old to do well on my memory test, that 70-year-old just may need a little more practice. It's kind of like my 11-year-old son can do the computer thing in 5 seconds that takes me 5 days to figure out. He's already done it, okay? And I'm like trying to catch up. I get there, okay? If you come a week later, I can do it, okay? So part of the daily stuff is adjusting your expectation and slowing down. The second thing is to go back to learning things with more than one sense, like we used to do when we were in school. So now we're very passive when we learn and try to remember. You read the book, you put it away. You go to the movie, then you go out to dinner. You read the list of names from your board meeting or whatever and put it away. So I suggest you add another sense to that. So when you finish the chapter of the book, can you say out loud what that chapter was about? It's really harder than you think. When you leave a movie, turn to your friend and see if you can say who directed it, who was in it. I mean, just literally right when you walk out. Say the names of the people you want to remember, physically write them down, and I don't mean on the computer. There's something about physical writing that's a different brain process from computers, actually a new kind of area of research that's interesting. So that's the multi-sense. That's the second thing, along with slowing down. And the third thing you can do is related to what Dr. Martin was talking about, improving attention. Again, that's the take-home message here. I call it brain buzz, okay? So anything you can do to reduce brain buzz, meaning you're getting ready for a big presentation at a meeting, but the phone is ringing, it's your long-winded friend on the phone, so you're on the phone, the TV is on, you've got a doctor's appointment in 25 minutes, et cetera, et cetera. Did you get your husband's dry cleaning? Oh my God, I think I forgot. Okay, and then at the end of that half hour, you're like, oh, wow, I'm not really prepared for this meeting and I can't really remember what I was gonna talk about, right? That's brain buzz. So as we get older, we have to get ruthless to remove the variables of brain buzz. And seriously, if you do this one thing, you'll notice a difference in your daily life. You do not answer the phone, you turn off the TV. When you have the thought about your husband's dry cleaning, you write it down, you get it out of your brain on your one piece of paper that tells you what you're doing that day, okay? You've exercised, you've had healthy lunch, right? Now you're going to take half an hour to review what you're doing for this meeting and try to remember. It's really surprising as we get older how inefficient we become at learning and remembering when our minds are just cluttered with brain buzz. So those are my 3 tips I'm going to give you for now, and I'm going to stop so that we have time for Dr. Nugrishel and Dr. Sano, but we'll talk again in a little bit with questions and answers. Thank you.
You were 10 minutes and 17 seconds. You were awesome. Oh, good. Hi, everybody. A lot to think about. Definitely a lot to think about and a lot of really interesting tips. So I'm going to change focus a little bit, a lot. And I wish I could talk about all the things that Dr. Martin suggested that I was going to talk about, but
10 minutes.
That's not going to happen. But I will suggest that any of those topics that you are curious about, that we're leaving a lot of time for questions and answers. And so things that we don't cover, please bring them up in the Q&A, and then we will have time to discuss those. So my job at this moment is just to tell you that, so Dr. Sano and I are going to tell you a little bit about who we are and what the current direction of research is in Alzheimer's research. So I'm doing the who we are part. So our Alzheimer's Research Center was founded in about 1984 by Ken Davis, and it was defined as a research center. So some Alzheimer's centers are just clinical, and some Alzheimer's centers are clinical and research. And by having that R in our name, or an ADRC, that means that there's a whole host of people who are doing very significant basic science research, looking into subtle molecular changes, trying to understand the molecular mechanisms of how, for example, diabetes and Alzheimer's might be related in the brain, using various kinds of modeling. Very intense, very interesting. We are more involved in the clinical side. And so in the clinical side, our ADRC has been involved in some of the very earliest studies of the cholinesterase inhibitors. You've all probably heard of Aricept. So that class of drugs, we were involved in the earliest trials in developing those drugs. In fact, there's an outcome measure that's used in every single Alzheimer's clinical trial called the ADAS-Cog, and that was also developed at Mount Sinai. So we've been intimately involved in the clinical research looking for treatments for Alzheimer's disease for 30 years. And right now, we're trying to understand the expanse of this disease. What Dr. Sewell and Dr. Martin were referring to, that, in fact, there's a spread of symptoms, and there probably are changes in the brain that happen prior to any symptoms at all. And this is, as a paradigm, it's not an unusual paradigm. If you think about Parkinson's disease, it's been known for 30 years that you have to lose, I'm making up this number, but 85% of the cells before you actually get a significant physical symptoms of Parkinson's disease. And so the idea that there are proteins that are accumulating in the brain for a long time before symptoms are present is not a surprising one. It's a scary one, but it's not a surprising one. And so we follow a cohort of about 450 people yearly, people who are completely normal, people who are worried, people who have MCI, people who have Alzheimer's disease. And we look at biomarkers, and we look at neuropsychological testing, and some of them are involved in imaging trials. And then Dr. Sano is going to tell you about the research trials that many people from the sample, as well as other people, participate in. And so our goal is to really try to understand this disease from its inception, and to think about ways that we will be able to intervene in the future to really make an impact on its development over time. So I'm going to hand over the mic to Dr. Sano, who's going to tell you about the research.
Thank you. I also am short and need this step. And I want to thank you for allowing me to talk to you for a few moments. First, as Judy has just introduced the topic of an ADRC, an Alzheimer's Disease Research Center, we refer to ourselves as a translational center. So the work that happens at the bench and in the laboratory, we take to the clinic. It's not simply a study of what goes on in a mouse or in a piece of tissue. It's an idea that what we find there can lead us to find the biological mechanisms that hopefully will lead to treatments. So let me talk a moment about the concept of prevention of disease. Now, you've just really heard probably the top-notch description of what you can do, right? Many of you are nodding your heads, so you're already doing it. Or you're doing some of it. And a refresher is really important. It's very important to remind ourselves that this is a process of engaging in good health for our cognition to be sure that our performance is maximized. However, when the day is done, we know this disease still exists, and it doesn't exist because people didn't exercise, and it doesn't exist because people didn't take their medications. Alzheimer's disease is a biological entity, and our goal with all of our prevention work that you've just heard about is to be sure that we're maximizing our function so when the disease process starts, we're at the top of our game and we have the least symptomatology for the longest amount of time. But then the disease does exist. We know that Alzheimer's disease is characterized by amyloid and tau. These are two proteins that accumulate in our brain. And people say to me, but we haven't made any discoveries in a long time. And you know, that's just plain not true. One of the things that we've been able to do is to measure these proteins in the brain of a living person. In fact, the amyloid imaging is now actually commercially available to help us define the diagnosis of Alzheimer's disease. Amyloid in the brain is thought to accumulate at least a decade before you actually have any symptomatology. And right now at Mount Sinai, we're beginning to conduct studies of what we call secondary prevention. These are people like you and me who are in good cognitive health, but for some reason may have a risk factor for which we can say they have the buildup of amyloid in their brain. And now we have an opportunity to offer them a trial in which we can measure the amyloid, and if it's there, we can offer them the trial to see if we can reduce the amyloid and get a benefit from that reduction. So this is just one study that we're conducting, and there are going to be more and more of these studies going on throughout the country, multi-center clinical trials. That's one whole mechanism of reducing the likelihood that the amyloid accumulation occurring before we have symptoms might actually prevent truly Alzheimer's disease, that which we define as Alzheimer's disease. We don't know. So what happens very often is people come to me and they say, oh, well, I want to be in the study, but I want to be in the drug arm, not the placebo arm, right? Right? But we don't know. That drug may not work, may actually have a little worse effect, not a better effect. We don't know. But we're never going to find out unless we ask the question and we do the studies. And so I am proud to say that Mount Sinai has an incredible partnership with its broad community of people who say, I want to know the answer. I want to know the answer for myself, and I want to know the answer for the future. And the concept of doing this kind of research in healthy people who join us as partners in the research is perhaps the greatest strength, the greatest army we have against this disease. We cannot do this in the laboratory. We really need to do it with the partnership of those people who say, I know this disease, it's terrible, and I want to see how I can help change the face of the disease. The other thing I want to tell you about is clinical trials always sound a little risky. People like to say, oh, I don't want to be a guinea pig. Well, we are, whether we join the trial or not. We don't know whether or not our risk factors, our family history, any of the biomarkers that we can measure, we don't really know for sure what they're going to lead us to. The partnership, and I really always refer to my participants in research as my partners. That partnership allows us together to go forward. In doing this in the context of a trial, we have the obligation, the commitment, and the privilege of passing the information on to you in the best way we can. You have an informed consent. When risk changes in the study, that information is passed on to you. When you have a personal finding that is inside the trial, perhaps due to a drug, or perhaps has nothing to do with the drug, that information comes to you, those of you who partner to participate in the clinical research. And so I really have just told you about one trial, the idea of removing amyloid from an individual who has no symptomatology but is at risk. But there are many other trials, both for people who have symptoms, who have mild cognitive impairment, who have frank Alzheimer's disease. Here again, we know we have treatments that developed because we had those partners who joined us in the clinical trials that Mount Sinai has been doing from the beginning. Ken Davis led the very first clinical trial to develop the cholinesterase inhibitors. And Mount Sinai's tradition of not just simply working at the bench, but translating it to treatments is longstanding and is going forward with this new goal of finding ways not only to treat the disease, but to prevent the disease. So I want to ask you to keep this in your mind. And when people ask me, what can I do to prevent Alzheimer's disease or dementia, I say three things. And you've heard about one of them. One is keeping yourself informed. You've just heard the most up-to-date information. And you know, it's not all straightforward. As you heard, it's a web. The most up-to-date information on how to keep your cognition as stable, as strong, as maximized as it can be, right? So keeping yourself informed. The second thing I say is support research. Through the efforts of people committed to Alzheimer's disease, the federal government is considering a very large infusion of research dollars to help us make progress. So support research, support it personally, support it politically, support it nationally. And I think the other way that you can support research is by supporting research as a participant. And it can be a participant for you, for someone you know, as a partner to someone you know. So when someone says, I'm thinking of joining a research study, instead of going, say, that's great. How can I help you do it? Help yourself stay informed, treating your treatable conditions, moving forward, and definitely thinking that we can't do this alone. We really need to have you join us to understand how we take the biology, which we're really moving forward in incredible ways, and taking this to the bedside to be sure that we develop the treatments we need. I'm going to stop here, and we'll be glad to answer any questions.
So there's not mics out there easily, so we're just going to repeat the question, unless you want to run these questions. Her question was, what about heredity?
So you handed the mic to me. All right. So let me just say one thing. Is there anything that you're not at risk for if your parents had? Right? So we inherit everything. But the question is really probably a little more precise than that. There's about 5% of dementia that's truly autosomal dominant and genetic. And those individuals come from families where there's very high percentage of dementia, and typically at an early age. But then there's also risk factors. The most common one is called apolipoprotein E, and the E4 allele is a genetic risk factor that increases the likelihood that you will have Alzheimer's disease. It is not a determining factor. Unlike an autosomal dominant, it is not a determining factor. So what can I tell you about this? We all have two E4 alleles, one from our mother, one from our father. If you have one E4 allele, population-wise, not you individually, but population-wise, your risk of Alzheimer's disease about threefold. If you have 2, it's about tenfold. Now, should I know if I have that allele? Well, what information are you going to get from that? If you do not have a family history and you have an E4 allele, you might have an escape gene that we don't know anything about. On the other hand, if you're starting to be concerned about memory, if you do know there was a fair amount of dementia in your family, perhaps that piece of information will modify what you do, particularly in the context of an evaluation. And in fact, our belief on this allele has changed. In 95, when we were actually first talking about it, we said there's no point in considering having a genetic risk factor done for a clinical purpose. But now, when we know that a person who has some concerns, who has an E4 allele, we might actually recommend that they have imaging testing to determine whether or not their cognitive complaints are legitimate in the early signs of Alzheimer's disease. So there is a little bit of information, but it's not 100%.
Do you recommend getting a baseline guide of where you are on your memory?
Personally, I'm biased. I do. Can you hear me? Again, we wish every 83-year-old, when they walk through the door, said, oh, wait, in my pocket, I have my neuropsych test report from when I was even 50. That would be great, or 60. That would be great. We do have ways, though, to figure out where was someone's starting point? Where were you at best in life in terms of your overall intellectual abilities? And so sometimes, I want to say another thing about that in terms of cognitive reserve. Unfair as it is, people with higher levels of education, occupational attainment, and basic IQ, intellectual abilities, are a bit protected. It's a little bit of a cushion, a buffer against the changes of the disease. So they'll present better. They might be deteriorating the same way as the next guy, but they will function better in day-to-day life. You can't just be a couch potato, though, your whole life and then start to be mentally active at 50. So cognitive reserve is important, but we figure out where was someone. We have ways to do that. Certain tests that we say stick, even in the face of moderate stages of dementia, even with a TBI. So yes, a baseline will allow us, will follow you. Now, in the research battery, people come back every year. So in a sense, it's a baseline. We're constantly comparing. And clinically, we have people come back annually as well. You look at a set of numbers. How did you do on that memory test last year? Then we have something to compare it to. It is helpful to get a baseline before there is something happening, but it doesn't matter.
Did I hear you correctly that 83-year-olds and over, about 50% have Alzheimer? Did I hear that correctly? Could you repeat what the statistic is? Or if there is one, really?
Right. So the statistic is actually over 85. The estimate has been that up to 50% of people have dementia or cognitive loss that's on the road to dementia. Now, I will tell you that the most recent data suggests that, in fact, that age has gone up a little. So that data really comes from almost 10 years ago, and it probably is a little bit less. I mean, while people say, oh, it's getting more common, in honest numbers, the onset is a little bit later, right? And our ability to actually see these changes coming in a little bit later, so that's a good thing. On the other hand, in a technological world, even subtle changes in your cognition can make you dysfunctional. And so while I'm very positive about the fact that we're taking care of all of those kinds of things that you've just heard about, and that's allowing us to keep cognition longer, I don't think we should be fooled. I think we have to acknowledge that the incidence remains high and accelerating.
I just wanted to ask you if all clinical trials are done against a placebo.
She's asking if all clinical trials are done with a placebo. Judy, do you want to actually answer that?
All good clinical trials are done with a placebo. Yes. Yes. Okay. So,
Wait, her question was, are they ever done against an existing medication instead of a placebo?
So often, existing medications may be included as acceptable medications to be taken by anybody, by everybody in the trial. So you don't necessarily exclude standard of care. What you want to see is whether this medication is going to do better than standard of care. So that is actually a pretty common way of testing it. But if you really want to know whether a medication works and that you're not getting a placebo effect, you really need to test it against a placebo. Yeah, they're not all studies, by the way, are designed so that it's 50% placebo, 50%. There may be, let's say, 30% placebo, 30% one dose, and 30% another dose. There are lots of ways to design trials. There are other trials where, people are on, one group is on a placebo and then they start the medication, another group starts on the medication and then goes on to a placebo. There are lots of different iterations to kind of get at the same information. But it's sort of like anecdotal evidence doesn't really tell you a lot. And you really have to do things in a rigorous, double-blinded way so that you're not influencing the results of your studies.
Other than advancing the studies, how does the patient actually benefit from this knowledge?
How does the patient benefit from the knowledge of participating in a clinical trial? Right. So it's my belief that there are, in my mind, three major advantages. First of all, nothing gives you more information than a clinical trial. As much as your doctor will try to share with you every concern they have, they probably see you at a much less frequent rate than you are seen in a clinical trial. So your disease is tracked along with the effect of the treatment. So that's really important. And if there's a change in your disease or a change of information about this drug, it's passed on to you immediately. Secondly, you have this opportunity to get exposure to a treatment usually earlier than if it works, if it's available, than you would if you have to wait for commercial availability. Most clinical trials will say you're randomized to a drug or a placebo or whatever the conditions are. At the end of the study, you go into an open trial, so you'll get exposure. Now, there are exceptions. For example, if the drug isn't safe, you may not go on, or if the trial is stopped, you may not go on, which would be quite different than if you were taking the drug on your own. So this is a second way to have safety. And then there's a third thing I wanted to mention, and just as Judy was saying, in Alzheimer's disease, our clinical trials are done on top of standard of care. We do not withhold the maximum treatment, and in fact, there are studies that will not take you in unless you've been tried on the standard of care. So we know you've gotten the full knowledge of what's out there to treat. You've been treated with it. If it doesn't work for you, you might stop, but then we know that you've gotten everything that exists at that moment in time. So I think those are the three types of things. But the final thing I want to say, no matter where a person is in their life, whether they're perfectly healthy or losing their cognition or dementia, my experience is people say, I want to make a contribution. And when you participate in clinical trials, you are making a contribution not only to yourself and to your family, but to the health of the general public. And it's a real contribution that no one can ever minimize. It's a real altruistic reason for people to go forward.
I'd like to add to that. People would often ask me, well, I'd like to go to the health food store and buy ginkgo biloba, or when we were doing the red wine study.
Don't do that, by the way.
Yeah, right. Resveratrol, et cetera, some miracle memory drug. If it were out there, believe me, we'd all have it. So I say, hey, you're risky. You want to try something? Do it in a controlled way. Don't go to a health food store, save your money. Come to a research center like Sinai where you have, you're watched and you're in a trial that's regulated.
I'm just gonna add one final thing on this question. We all have to, because it's such
It's
an
a
important
team of women.
It's such an important question. We just collected some data last year about this very question. I mean, why do people participate in a trial? What are you getting out of it? And one of the most common answers was the community that they became a part of, the relationship with the staff, with other families participating in the center, with the activities in our center, with the things that they're learning, and also, of course, the hope that their participation is going to affect our children and their children. But the relationships, and since there's a lot of women here, it's probably understandable, it's the relationships with other people that was a big driver in why people wanted to participate.
I'm curious as to how these two things affect memory. One is chemotherapy treatment, and the other one is pregnancy.
Okay. Well, I'm going to address the chemotherapy section of it. So the question is, how does chemotherapy and then pregnancy affect memory? So there is a condition colloquially called chemo brain, which refers to the cognitive changes that can result from chemotherapy that are sort of across the board. It's not just memory, but it's things to do with attention and concentration and processing speed and even verbal fluency that can be quite traumatic. And in our private practices, we certainly get many referrals of women of any age really concerned that something horrible has just now happened to their brain. The good news is that these are usually temporary changes, and almost all of this, from a research point of view, in terms of looking at the testing, of those kinds of symptoms resolve within 6 to 12 months with the cessation of the chemotherapy. In all honesty, I can't really address the pregnancy one. I don't know that much about it except to know that hormonal changes wreak havoc on our cognition and are usually temporary, but I don't know that literature.
I looked it up really briefly when I was pregnant, and basically it's the same. I mean, except it's obviously not as toxic as the chemo, but those wild hormonal shifts do affect attention, concentration, mood, all sorts of things, and that all affects cognition. And that, at least it's a fairly scant literature that I saw, but what I saw, it all resolves.
And then
the baby's born.
And then we're back to attention, because with a new baby, you're not really sleeping very much, and that affects, as you all learned today, your cognitive functioning. So there's a lot of variables to tease out.
I don't think I've had anybody on this side, so.
The doctor of my 89-year-old mother said, she has dementia, but she doesn't have Alzheimer's. So I wonder what that means. And I also have a question about dealing with depression and taking medication for the depression and how that medication affects your memory.
Okay, I'll do that one. So she has dementia, but she doesn't have Alzheimer's disease. So that's a tough one, because the next question should really be, well, what kind of dementia do you think she's got? Because the most common, let's say 70% of dementias are Alzheimer's disease, and particularly if you're 89, maybe even higher. There are lots of other things that cause dementia: strokes, Parkinson's disease, long-standing substance abuse, Lewy bodies, and they're all associated with frontotemporal dementia, another kind of neurodegenerative dementia. And they're all associated with slightly different patterns of loss. So, for example, in Lewy body dementia, you often will have very vivid visual hallucinations very early on in the disease, and you'll have often very mild Parkinsonian symptoms that start off in the disease, whereas as opposed to Parkinson's disease with dementia, you often will have Parkinson's disease for many, many years, and then later on develop a dementia. So I'm just giving you those as examples. There are lots and lots of things. Sometimes people say that because they don't really know, and it just feels more reassuring to say that. And you know, obviously depending on the person and how they're feeling you're feeling, you know, that may also play into it. So again, I don't really know.
Well, with Alzheimer's, aren't there physical things that break down? You know, you're eventually unable to breathe or eat.
Eventually, but that's over the course of, you know, 10, 12, 14 years. The question was, are there physical changes that happen over time? And then, so basically, as a, you know, what we didn't spend any time talking about, but dementia is a process. So it begins with maybe memory symptoms, mild symptoms, difficulty with the checkbook, difficulty with executive function, and then moving on to more, you know, inability to, let's say, feed yourself or to dress yourself, and eventually ending up being bedbound or forgetting how to swallow, and leading to pneumonias and leading to death. It's a very, very long process, and people don't necessarily make it through all the stages. They may, you know, have a heart attack and not go the whole route. But it's a long and complicated process. But in the early stages is where dementias look most different from each other. Late stage, most dementias look quite similar. Now, just to answer briefly your question about antidepressants, is that antidepressants can be, if the person actually is depressed, antidepressants can be quite helpful. Sometimes people try to treat symptoms of apathy with an antidepressant, and they don't really help very much. So, yes.
So could you comment on the education of primary care physicians and general physicians on distinguishing the different dementias? What I find is that a lot of people are told they have Alzheimer's, and then they come to someone like me and they don't have Alzheimer's.
Dr. Schwab, would you like to talk about what we just did in our CME course?
No, I will let you do that. I'm making you do too much about it.
Well, I think that yes, I agree with you. I think there is a lot of work being done reaching out to primary care physicians, and as you know, primary care physicians are a pretty overwhelmed bunch of people with a lot of things being thrown at them at all, you know, every organ system. Sorry, can you hear me? Yes. Okay, sorry. That primary care physicians have a lot of
You repeat the question.
Oh, the question was why, sorry, I'll start again. Rewind. The question was, why do people come from primary care physicians with some kind of very vague, this isn't Alzheimer's or it is Alzheimer's, and then when they get seen by a specialist, something much more concrete is defined? And what is being done about training primary care physicians? And, you know, what I was saying to Dr. Schultz, was that the geriatric medicine department has a lovely continuing medical education course that they do every year. And this year, Dr. Schul and I were given the task of doing non-Alzheimer's dementias for primary care physicians. So it's, you know, I think obviously primary care physicians have an enormous amount of stuff that they have to know from every organ system in the body. And it's important for them to get a sense of what the different kinds of dementias are, and particularly depending on what their own patient population is. So if they're primarily treating 40-year-olds, it's probably less relevant for them. And if they're primarily treating 80-year-olds, it's probably more relevant for them. But then it's important for them, what I really want them to be able to do is to recognize that there is a problem, and then to refer them to somebody who can help define it more clearly. Now, there was somebody in the back, and I was feeling all guilty about back. Oh, wait, look at one more. Oh no, you guys gonna do rock, paper, scissors?
Mine isn't such a good question. I'm just curious, 100 years ago, did we call it Alzheimer's? I mean, when you think about your grandparents and great-grandparents, if any of you remember, I don't remember growing up and hearing about Alzheimer's. Where'd it come from?
So the initial diagnosis of So the initial diagnosis of Alzheimer's disease came from Dr. Alzheimer, Alois Alzheimer, who was actually not studying what we call sporadic Alzheimer's disease. He actually was studying Auguste D., a young woman in her 50s who had a genetic form of Alzheimer's disease. And from that beginning, we began to identify the pathology in the brain that's associated with dementia, and a specific dementia, Alzheimer's disease. So out of this concept of a young woman losing her cognition too early, we became aware of the fact that losing cognition is not normal. And as we have expected to see people live longer and healthier, we now become aware of losing cognition is not normal. And I think you're right. You may not have heard it diagnosed from your past generations, but number one, they did not live as long. And number two, they did not live as well. And so the opportunity to observe it was minimized, as was the chance to observe it, because the complexity of life was relatively simple and their cognitive and functional loss might be missed.
So apparently we must stop. I've gotten the sign, but we will be around, and so we are happy to continue to answer stuff.
On behalf of everybody connected with this day, I cannot thank you enough. You have given us so much food for thought, so much information, and we really appreciate the fact that you've given up a whole morning to be here with us. So thank you again, and our deepest gratitude. You were fabulous. Do you need a new patient?